Welcome everyone. This is the fifth and next to the last installation of the Drones in the Coastal Zone webinar series. We do have a couple icebreaker questions, which maybe you saw before my picture showed up. We'll get back to those in a minute. My co-host is is Abby Wakely, and she's going to be helping make sure we stay on time. I'd like to draw your attention to the website up on the slide. It has a lot of background material, recordings of previous webinars, and research paper, etc. So please check that out. I'd like to remind you that we are recording the webinar so that it'll be available to anybody who would like to look at it. It should be up and available on that same website within the week. Quickly, a reminder of the goal for this series. It's to improve awareness of the emerging issues in coastal management, state of the science, and regulatory policies related to drone technology. I'd like to thank the sponsors. I know many of you have been with us for several webinars now. They remain several contingents of NOAA, the Southeast and Caribbean Regional Collaboration Team, the National Centers for Coastal Ocean Science, the National Estuarine Research Reserve System, and then several of the ocean observing partners, the IU's Program Office, SOCORA, which is the Southeast Coastal Ocean Observing Regional Association, and also CARICOOS, the Caribbean Coastal Ocean Observing System, and finally our resident experts, the Duke University Marine Robotics and Remote Sensing Lab. I also need to give a quick shout out to the planning team, which includes Abby and myself from SOCORA, several NOAA folks, Stephanie. Yes, great. So first up, we're going to have a great panel of 4 speakers focused on data management and the challenges and opportunities related to drones from the federal, private, and academic perspectives. And then we'll have a quick coffee break and move into a demo on mission planning, and then close out the session promptly at 12. So as I mentioned, our focus this morning is an overview of data analysis, data management, and stewardship. There's going to be an awful lot of it, so it's really important to have a plan, which gets a bit to the poll questions about how you would describe the organization of your personal or family photos and videos. And it looks like the majority of folks who've responded so far have indicated that they know where to look for them. There are a few of us, and I count myself in that group, that clicked a hot mess as the response. And then we apparently have 6 very organized souls who noted that they are the Marie Kondo of video organization and know how to find absolutely everything. And hopefully with our chat this morning, our presentations will get some insight in how to do that for drone video. We also have a second icebreaker up about what you'd like to learn today. If you have some thoughts there, please pop them into the chat. It'll help give our presenters some ideas about where to focus on, and I think will help lead to some great discussion as we move through this morning. So as a reminder, please use the chat box for your questions. I'll be monitoring that. We are going to hold all questions until after the presenters have completed their presentations. First up, we have Julian Dale with Duke University. Julian is the lead engineer with the Marine Robotics and Remote Sensing Lab. His work includes custom engineering aircraft and payloads specific for marine research. He's also a pilot instructor and maintains the lab's 45 aircraft. He has over 980 flights and 250 hours piloting UASs all over the world. And so, Justin, I will hand off to you.
Okay, thank you very much for that introduction. Let me just share my screen here. We're going for the risky approach today and doing another live demonstration, so hopefully this works well. Hopefully you can all see these slides here as well. Excellent. Okay, so I'm going to give you a brief overview on some of the metadata that we collect as a lab, particularly from an engineering perspective and a project management side of our operations. So what we found is, as our lab grew, we really needed to get a much better handle on the data that we were collecting within the lab. And this has been a work in progress as the lab has expanded. So this includes things like our fleet management and maintenance of the aircraft, our pilot status, so that's the total hours, training, skill level, and also keeping record. This is very evident when it comes to permitting, being able to prove competency with pilots. Wrapping our arms around our projects and making sure that we've got all our documentation, risk assessments and permits, as well as recording all of the flights associated with that. And our data, making sure we've got some transparency right from our flight logging through to archiving that data. And finally, as the fleet grew, is the inventory as well. Where is all our equipment? Where's it being stored? So that we can go back and find that or when we need it. So one thing that we did find as it grew, using simple Excel and things wasn't quite cutting it. Unfortunately, we haven't managed to find one system that does all of our data management. So we use three different systems, one for project management, one for flight management, and one for inventory. These are some brief requirements that we had for those. One particular one was working offline with the flight logging when we're working in remote locations where we don't have an internet connection and we can sync to the cloud to pull that data up and down. We needed to record all our batteries, be able to make field notes, record any instances, and access to all our checklists and things like that. The inventory management, there was a number of software packages available, but it had to be simple to use and customizable as well to fill in the extra fields that we needed to record. Just briefly touching on our flight records, we have a number of naming conventions that we use. We have two main ones for our flight mapping flights and our photogrammetry flights, and you can see the structure that we use here. It became very evident it wasn't so much just in the initial project processing, but as we started to move this data around and archive it within a file structure, these file names got so long that we actually ran out of characters. Also being able to link these flights back to the flight log to be able to pull out specific information about the flight became really important when we're looking at errors associated as well. So those are just a couple of examples. So I'm going to jump over and just give you a run through. So Drone Logbook is the software that we use for all our drone operations and project flight record keeping. So we've got a basic overview here of where we sit in our stats and our flying times. First, I just want to take you to our flights and an example of a flight. So every one of our flights gets logged. So we keep track of aircraft, batteries, sensors, all those kind of information. You'll see a naming convention here. I've just cloned a flight for this example here. But within this flight log, we're recording all the information, distances traveled, the personnel involved, the batteries used. We can record our documents here, so any pre-flight checklists and things like that get attached within these flights. And we can also import all of the flight data from the aircraft So we get start end voltages of the batteries, an overview of where that flight took place. You can get altitude information in that here, so we can scroll across. I don't know if you can see the moving map there where the aircraft was. And in some instances with the DJI aircraft, we can even get snapshots of what was captured during those flights. So it's a really simple way to record all that information, and specifically recording notes in here as well. The next that became really important, particularly for me, was our inspections and our maintenance, keeping track of where all our aircraft were in terms of their maintenance. So here in our inventory, in our inspection page, we get a brief overview of all the different aircraft and where they sit in terms of flight hours before their next inspection. And if I click on this aircraft, we can set up custom inspections for each of these aircraft. So all the different components that we want to check and time intervals. Some of these are pulled from the manufacturers themselves. A lot of manufacturers don't have any specified inspection or maintenance protocols, so we just apply our own to those, so that every aircraft goes through at least a 10-hour inspection of all these various components. So we keep track of all the aircraft within that. If any aircraft does require any maintenance, we have another separate maintenance tab, and we can actually schedule maintenance. We have maintenance that's in progress, so aircraft that are maybe out of service for one reason or another, and then we can look back through for any aircraft maintenance that has occurred. So if there is a problem, or when we're actually looking at component life expectancy, we can see how long those components take before we're finding they're breaking in our scenario. The next was keeping track of all our pilots, their associated documents, and their flight hours as well. So within this, we record all our pilots. I'll just scroll down to mine. So this will give us a breakdown of the aircraft that we're flying, the amount of flying that we're doing. Again, we upload all our documents here so that we have a digital copy of all these pilot certs or anything that's associated with those pilots. We also have a skill matrix. I'll just go back to the personnel. And within this, we can actually get an overview of all of our pilots, and these are customizable categories here. So as your pilots become skilled or proficient in various types of aircraft, have different approvals, regulatory approvals, or for using different software, for instance, then we can set up this matrix so we can get a brief overview of where everyone sits within the organization. When it comes to our projects, all of our projects sit underneath a project folder. So all of those flights that we do are also tagged with a project. So we can go back in within any project and look at the total number of flights. Again, any documents that are associated with this specific project we can attach within here. And we use this in particular when it comes to our grant reporting and billing and things like that. So we can actually work out how many flights we've done on that particular project. So within our document section, this is where we create checklists. So we've got specific checklists here that we can create for doing pilot evaluations, aircraft pre-flight checklists. We can also create risk assessments. So if we have standard risk assessments, we can create those here. COVID field operations is one that we've just had to do recently. So these can be attached within the project. And finally, within this is our incident reporting. So any incident that happens with an aircraft, anything that's abnormal, a hard landing, that gets logged within the system. I get notified of that, so I know to go and check that aircraft out thoroughly to make sure it's still airworthy, or do any repairs. But this also keeps track of any of those incidents, should they be reportable to the FAA. Thank you. And finally, our inventory management is the last system that we use, just keeping track of all these different bits of equipment. So here we plan out this various bits of equipment, and Go to one of our aircraft, for instance. So we know here all of this data is captured. We know the serial numbers should this aircraft get lost or stolen. We can bring up a map of where it is. We can also flag it as well if it needs clean air inspection. All of these items actually use a very basic QR code, and that is scannable in an app when we go out into the field. So this is a very easy way to keep track of where everything is, who's got it, and when it's been booked out. So that was a very, very brief introduction onto at least two of the systems that we use. And I'd welcome any questions if anyone has any specific questions on those.
Great, thanks very much, Julian. I'll ask folks to put questions in the chat box for now and introduce our next speaker, who is Sharon Misick. Sharon is the Chief of Information Services for NOAA's National Centers for Environmental Information, Oceanographic, and Geophysical Science and Services Division. She's leading development of NOAA's Unmanned Systems Data Enterprise, which is planned to draw upon agency-wide assets and capabilities to provide environmental data corresponding to NOAA's strategic initiatives. And she's going to talk about the workflows for submitting data for archiving. Welcome, Sharon.
Thanks a lot, Deborah. Hi, everybody. Thanks for having me. I'm looking forward to the opportunity to talk to you about how we archive data at NOAA. I'll say up front that we are just getting off the ground, no pun intended, with managing digital video, particularly from aircraft systems. And so a lot of this information today is based on our experience managing video from underwater systems. There are some parallels there clearly. Also, I have a lot of information in here. My final slide has links, and also in the slide notes, additional links to resources where you can look at this information yourself. So again, this is what we're going to go over quickly today, what the NOAA archives are about right now and where we're going in the future. Digital data management, focusing on our video experience, and then some resources to help yourself and help us help you. So this is an overview of the archive today, and this is literally true. We warehouse a lot of physical inventory still, going back in some cases more than 100 years for these physical archives. And of course we have on-premises systems for our digital data. This slide is an overview of our digital data holdings. The vertical red dotted line is where we are now. Digitally, we maintain backup copies essentially of everything that we've got. So we've got a 34 petabyte archive with the backup copy. Of course, that's closer to 70. And you can see this anticipated exponential rise in data, which is attributable largely to the increase in satellite systems, models, and of course unmanned systems, which we do feel like will bring exponential growth. So clearly we are not managing those in the system that I described to you in the previous slide. What we are trying to do is apply these transformative technologies. That is a link to the NOAA Research Council website that describes these four, and there are a couple of additional ones. Essentially, the uncrewed, which is our new word for this, the uncrewed systems implementation plan calls for us to build an encompassing and innovative data enterprise to efficiently centralize the management of all of these assets. Of course, that's quite a tall order because we're talking about everything uncrewed. So there are sort of two categories there, the aircraft and the maritime systems, and then a range of systems underneath. The data strategic plan will focus on the Evidence Act and how we're going to modernize the way that we manage data as a strategic asset. The cloud is going to be, the platform that we are moving to. Some data are there, some data are moving there. Not trivial to move the archive up there and to develop new workflows to put data in the cloud, but that's going to be the answer to the volume issue. And then artificial intelligence based on data residing in the cloud is going to help us with our analysis and making data findable, accessible, more readily interoperable, and of course to increase the reliability of the data. So with that background, let's talk about digital data management and you. The archives have developed a stewardship business model. We are not able at this point to keep up with the demand with our current resources. And so we've come up with a plan to appraise data for archive using objective criteria, and that helps us selectively meet the high service demand and to make the best use of our resources such as they are. So you can see here the 4 components. We look at NOAA's mission. We look at the volume of data, we look at the tier of stewardship, which I will describe to you, and data complexity, which is a term that may not be intuitive, so I will describe that a little bit further. Oh, let's see. So the 2 areas where you have the opportunity to facilitate the process for yourself and potentially save money on archive are in the stewardship tier, which reflects the level of service you want from the archive and the data complexity. Here's a simple explanation of the tiers of stewardship. Tier 1 is your entry level, and what that means is that we can take your data as an object, write one metadata record, put it into a deep storage, which may even be nearline or offline storage, so it is retrievable to you the way that you submitted it, but it does not meet external user needs for easy reusability, for example. That is probably the easiest solution. It is the least tailored solution. If you look up towards tier 6, it is much more resource intensive, but it enables others in the community to access your data from the archives in a customized way. So we have an example of the tier 6 to show you here. The thing I really want to talk about is something that Julian passed over without putting a label on it, but something apparently that they do at Duke. And this is a key approach to data simplification, which is called sheer curation. So the term sheer curation, think about the sheer drapes that are hanging over the windows in your house. They let the light through, but it's not a heavy load, right? It's not light blocking, so forth. So that's the term. What it really means is think about the curation needs of your data, the need to preserve it and share it and publish on it right from the get-go. It's an old saw that time spent in planning is well spent, and it saves you time in execution down the line. And never is that more true than with data management planning, especially with the types of volume that will be collected from these unmanned systems. And so you want to think about this right from the beginning. As you organize your files, you set up your file structure, you set up your naming conventions. Throughout the whole process, you're thinking about this. The other thing you want to think about is, can your sensors record their own metadata? Can they use embedded channels, for example, in your video codec so that the essential metadata is inherent to the file and is not separate like in an ISO record? So think about this a minute. If you're making the data available to the public online and it's discoverable through a metadata search and the user accesses the data, they don't always get the metadata with it. So if you put a lot of effort into your ISO metadata record, it facilitates discovery and it may facilitate access, but the details about how this data was collected and how you may use it in the future when you're not around to explain it to someone are in your ISO metadata record. So you want to embed metadata to the fullest extent possible in the file itself. The alternative is what we typically... I'm sorry? Okay. Thank you. The alternative is what we typically see now, which is that scientists collect the data for their product or project and they generate their products and then they give it to the archive and they expect service on it, and it's a much heavier lift. So this is important conceptually. This next slide talks about your top 5 practices to reduce data complexity. We talked about planning. We talked about the metadata need to embed this, as well as develop standardized ISO metadata records for publication. Very important to organize your files in a structured way. Very important to set up a standardized naming convention, and important to think about format versus volume. So this is a key thing here. The best practice really is for the producer to keep the original copy of the data, to encode the data differently for archive to possibly a lower resolution or standard codec, and then to make a proxy version available for viewing, which is lower res. We've developed a system at NOAA for one particular partner. This is underwater video that does just this. If you're interested in this, there are some publications linked in the last slide. But what's essentially happening here is there's a custom user interface. The user can search the ISO metadata record with a high degree of accuracy, preview the data, and then if there's a need to obtain the high resolution clip, there's software that reaches into deep storage, pulls it back, and delivers it via shopping cart. So that's an example of Tier 6 stewardship. Here's an example of the content that we combine over the time code of the video itself to produce an ISO-rich metadata record which refines the search. This is a process that's moving rapidly to artificial intelligence. We're in the process of training data sets now for the automated annotation to make this more generally useful and applicable to legacy video collections in particular. So these are the overarching challenges that we deal with in trying to archive these data. We cannot archive data that is not going to be publicly available, all or in part. We do not archive PII, essentially, private information. So if you're flying over coastal zones and you've got somebody's house or somebody's waving at you from the ground, no good. Got to cut that out. It sounds a little simplistic, but we don't archive empty files or corrupted files, and so we will send these back to you. If you define a convention, I kind of really don't care what it is. I just want you to stick to it. If the software that we develop to ingest your files throws your file out because you have violated your own convention, we will send this back to you. And these top three here really relate to the difficulties of managing large volumes of data in our current setup, which we hope to graduate to the cloud and kind of solve that problem. In terms of resources, thank you. Here's where we go to learn more about archiving in general. There is very little resource here about digital video. I'll come back to that in a second. You do have two avenues of approach here. The send to end is kind of like a quick start. If you were to have data files less than 20 gigabytes, which you will not if they're digital video, you can submit these, develop your own metadata in our online tool, and it's an easy on-ramp into the archives. In general, anything that's more than 20 gigabytes requires a little bit more process, and here's the on-ramp there. If you need help with these, we've got posted here at the end our contact information, and someone will reach out to you specifically and help you with whatever your questions are. The key takeaway from this, I think, is that we have the framework here to develop a community of practice, and this is what our uncrewed systems data enterprise is going to be built on. We know that scientists are practicing their science using these new technologies, platforms, and sensors in the field right now. We don't want to dictate data management methods that don't take advantage of what the scientists already know. You clearly are all managing the data to meet your scientific needs. How can we work together to curate the data that, during your process, what I described as sheer curation, how can we work together to leverage what you're already doing and apply the best lessons learned to the community as a whole? So here you see a slide from the Consortium for Ocean Leadership stakeholder meeting that we had about unmanned systems or uncrewed systems in August. This report is available online, and it may be of some interest, but also here are the key takeaways for this. And so, my closing to you is an invitation to join us in solving some of these problems, preserving your data for the long term beyond your immediate scientific need. Here's the reference slide that I promised. Again, look in the notes for any of these links that may not work in an embedded form. And here's our closing slide. This is our contact information for general customer service. If you have any specific questions or need help with a specific project, reach out to us here in the subject matter line. You can put Socorro or drones in the coastal zone so it'll jump out at us. And we'll send you to somebody who's working with the kind of either science or data stewardship needs that you have, and we'll help answer those questions directly for you. So thanks for your time. I know this was a lot of information in a really short time, but there's a lot to cover here.
Great. Thank you so much, Sharon. That was a wonderful overview of what's happening with NCEI and some good provocative suggestions for how to work together so that we're all making progress with managing these huge data files. Next up, I'd like to introduce Evan Cook. He is the GIS manager for the Marine Resources Division of South Carolina DNR. Evan provides support to in-house research and management on all things geospatial, including the use, promotion, and development of UAS applications and methodologies. And he's going to talk to us about an internal South Carolina interagency-specific UAV database. Evan, welcome. We can't hear you yet.
Evan, depending on how you closed your webcam earlier, you may need to disconnect your microphone.
All right, can you hear me? Great, great. Sorry about that. Well, before I begin, I just want to say thanks to all the presenters, participants, and especially the organizers of this workshop. I've really enjoyed it so far. Thanks. So getting right into it, I'm going to talk specifically about our interagency UAV database. Kind of a brief outline. This is something that kind of developed out of SkyDuck, so I'm going to kind of discuss that a little bit further. Then move into, what did we want out of a UAV database or project database? And then get into some of the nuts and bolts in terms of design and functionality. And then some of the kind of the key features we identified moving forward. So, for those that don't know or aren't aware, SkyDuck is a South Carolina Interagency Drone Users Consortium. Basically, this began about 2 years ago, and it's you can see our mission statement there: to provide a forum for the South Carolina public sector to communicate, collaborate, and share resources in serving the state through UAS technology. There's our website there. If you are in the public sector in the state of South Carolina, I highly recommend you visit the website and check us out and join. We'd love to have more members. So, kind of in the development stages of SkyDuck, one of the key features we identified was, data sharing and collaboration. There are a lot of UAS folks, in terms of data managers and pilots and et cetera, and groups that are collecting data, but that information really isn't shared at this point. We don't know what we're doing. So that was one of the key things we identified in terms of developing through SkyDuck, is some kind of system to share, like, hey, I collected data here on this date, and this is the type of data I collected. So where do we start? Kind of in these talks, we discuss this huge database with imagery stored there and video stored there, but really that kind of wasn't realistic at this point. Where do we store that? How is it accessed? So we all kind of agreed that we need to just start small. Just knowing what data are available is enough for now. And then once we know where it's at and what was collected, we can just reach out and contact that individual. So what are the considerations we kind of identified? You might have seen this in some of the previous slides. Ease of use was the biggest one. So as we're trying to grow this database, we want more users to use it. we need it to be simple and easy. If it's too complex, people are just going to dismiss it and they're not going to use it anymore. So additional consideration is types of data. So we kind of identified aerial imagery in terms of, orthomosaics, videos, just simple photos. Limiting access is a big one, because we don't really have any direction in terms of public availability of some of these data, and that was a big concern. We decided it's best to just kind of limit access to a few individuals as of now within various agencies and departments, and then specifically within those agencies and departments, limiting it down to just a select few. So moving right along into the design and functionality, basically how this is all arranged is it's an empty schema that's on a hosted feature layer on ArcGIS Online. This is through SCDNR's account. Basically this feature layer is drawn into Survey 123, which is an app I'll get into in the next slide, and that's where kind of users can submit their flight information and the data they collected and the location and date and contact information. And then in terms of data requests, everything's just kind of at this point done through dashboard on AGOL or ArcGIS Online. And from there you can zoom around and see what data were collected, where, and when. And in addition to this, all of this is managed through a shared group on ArcGIS Online. The nice thing about this is it works across different enterprise logins. So as long as you have an ArcGIS Online account, you can be included in this, and it can be all these apps and data can be shared. Just kind of a nice feature to kind of keep this behind a login and keep it between us. So for data entry, as I said, Survey 123 is a kind of a feature we identified as being the best. And if you are familiar with GIS, you'll kind of see this around more and more. Nice thing about this is it can be done through a mobile app on a phone or through a tablet, as you can see here on the left. And that was one of the big features that we identified was, hey, I just did a flight here over Charleston Harbor. I want to go ahead and get that uploaded and put into the database while the pilot is packing away the drone and all the materials. You can do that straight from your phone or from the tablet you used for the flight. And coming back to that ease of use, this is really simple. It's an app you download, you log in, and there it is. It's accessible. So also simplicity in the data. We don't want to take up a lot of time, so just real simple: first name, last name, email address, agency, department, type of data collected, and the date and a location. And on the right, you'll see kind of the browser version of this survey through Survey 123. Exactly the same. You can use a map to draw a polygon of your flight area, which is kind of a real convenient way to know where these data were collected. So in terms of accessing the data, that same hosted feature layer that's used for submitting new flights through Survey 123 is also digested into ArcGIS Online's dashboard feature app. And this is kind of an example you can see here. Currently the data is planned to be added here in the near future, but you can see all our flights from DNR here. And it's kind of a nice, easy way of interactively visualizing the data submitted through this project database with some kind of key statistics on the side, such as total footprint acres, the number of flights flown, flights by year, flights by agency. There'll probably be some opportunities to put some additional metrics in there as well. But once again, coming back, key identifying feature we wanted was simplicity, just to get this off the ground, and that's where we're at. This is still pretty preliminary, but basically an interactive web map. You can zoom in and out, click on the individual polygons and features. It'll bring up attribute information from the hosted feature layer, with kind of a flight name, a date, the organization, the type of data collected, once again, and most importantly, the contact information. So here I'm zooming around. I zoom in on Botany Bay Heritage Preserve. I see a footprint from a flight, and I click on it from July 16th, 2019, and this might contain some data I'm interested in. So I have the contact information right there for Gary Sundin. I can go ahead and email him and inquire more about obtaining these data or find out more information about it. So once again, really kind of a simple approach right now, but we hope to expand it further. And that's what I'm going to discuss here in this next slide. Moving forward.
2 minutes.
So, yep. So initial data loading. As you can see, we only really have the DNR's data sets in there as of now. But we need to kind of standardize how that data is submitted for that initial batch loading of past data. Expanding data and user accessibility. So do we want to make this broad? Do we want to include, UAV specific data from different applications, from 3D, point clouds? Increased functionality. Kind of once this gets up and going, definitely be a need for some kind of, user interface where we can query the data and filter it on the map as well, specifically by date, type of data, location, agency. So those are all really kind of important features that need to be included. Cloud storage. So right now, once again, all the data is hosted with the owner of the data, and you have to reach out and contact them. But maybe down the road we can find some room on a server somewhere within some agency or university, and we can store these data there. And if we decide to go a route where it's just purely orthomosaics, maybe we use something like, image server on RGS Online or through RGS Server. Another option is creating a public-facing version, so including the attribute field within the table, within the hosted feature layer, that can be in turn used, designated as a publicly available or not, yes or no, and then we can create kind of a hosted feature view where we have a public-facing version. So if you have an image data set that's part of a grant that has a DOI, we can perhaps provide access to that to the public. So another idea is develop a cool acronym for the database. As a public sector employee, we take pride in our acronyms, so I'm taking suggestions for that. And then, of course, robust metadata, which the previous two presenters discussed in detail, the key components of how important metadata is to the user, to the person accessing these data. And with that, I'll yield to the next presenter, and if you have any questions, let me know. Thank you.
Great. Thanks so much, Evan. That was a wonderful case study of what's happening here in South Carolina to meet the growing need around data management for UAVs.
Thank you.
Remember to put your questions in the chat, and we'll come back to those when we finish with our final speaker, who I'm happy to introduce. This is Kyle Wilcox, who has over a decade of experience working in the coastal and ocean sciences, where he specializes in discoverability, accessibility, management, and analysis of data. He started at NOAA in 2006 and is now Director of Engineering at Axiom Data Science, a technology and informatics firm helping to build a better understanding of the environment by increasing accessibility, reuse, and impact of scientific data. And I also have to give him a shout out as Socora's lead data architect. So welcome, Kyle.
Thank you very much, Deborah. Hello, everyone. Good afternoon. As Deborah said, I'm Kyle Wilcox. I work for Axiom Data Science. We are the data partners for Socorra. I'm going to talk about assembling large collections of data. Talk most about best practices, things you should think about now before your project is starting, rather than trying to solve a crisis in the future. I've got 10 minutes. I'm going to cover data management lifecycle, the basics, where you should start. We'll talk about a little bit about concerns about storing large volumes of data and how you should curate those for your service needs and your user access requirements. We've heard a lot about metadata standardization. I'm going to mention that and raise some questions we can all think about. And then I'm going to go through 2 example video data projects that we have worked on as an example. At the bottom here I have a timeline of my experience with ocean data management, and the red line on that graph is my experience with video data, so keep that in mind as I present. So here we have a data lifecycle graph. Someone mentioned in the questions earlier, or had a question about NOAA data management plans. I read a lot of data management plans, and this is my start. I cover all 6 aspects of it, and I make sure they're solid. Starting at noon, going clockwise. You're starting with the collection and quality control. How are you storing that data next? Where is it stored? How are you describing that data? That's the 3rd step. This is metadata records. This is the step that you're applying any standards that have been developed. You have the archive and preservation of that data. That's obviously going to include the metadata and the data. And then you have the access and discovery of that data. And finally, the reuse and transformation of it. These are your data products. These are your end users. This could be also an internal cycle. One data set coming off of a drone isn't necessarily one life cycle. You could be producing data from that mission that feeds back into the cycle as new data, and then the product from that can feed back in again. I see a lot of this in the wild. I see a lot of research local life cycles, fast iterating, and trying to figure out just like what can we use this data for, or how can we process this data to answer questions. There's absolutely nothing wrong with that. This is awesome. The problem comes in when you ignore archive and preservation and access and discovery for the entire research project, or for the entire life cycle. What can happen? This is the perfect situation, right? You have some data, you've got a user, you've developed a product, and they want it. It's because this is an emergency manager who wants a monthly, water level heat map, things like that. This is a problem everyone wants. Problem is when you ignore access requirements and archiving and preservation, this is what you end up with. Now you've flown hundreds of more missions. You have dozens of more users or more. You don't remember what that initial product was or what that initial user was. You don't remember their user requirements, but you're still supporting them. You still have this data product, and it's really hard to change. Maybe they based an operational system on that product already. If you had touched on the archive and preservation and access and discovery from the beginning and figured those things out, this becomes a simple problem, and without that, it becomes a very expensive problem. Going from this into something organized, well-documented, applying standards to data after the fact is not easy. So you have to really drive your storage needs through your access and discovery requirements. And what would this look like? Here's an example. You've got video data. You've got your level 0 storage. This is the raw data coming off of it. This is data used to answer science questions, and maybe not just your science question. If you're doing post-hurricane flyover of coastline, that can be used for erosion detection. Maybe that's what you do, but maybe someone else 10 years from now wants to use it for to analyze traffic patterns. Where were the cars submerged so they know what roads to close next time? Things like that. You want to save this data if you can think of a science question that could also be answered by your data. And maybe you don't think of it. Maybe you just have the idea that it could be used. Well, keep that data around and come up with an archive and preservation plan. Doesn't necessarily have to be NCEI. That's who we typically work with. From that data, maybe you're processing and you're labeling that data. You're producing a level 1 product and you're storing that. This is less of a storage requirement. You're annotating your video data. You're extracting clips from this data of the parts of the data that are interesting or solving your question. Maybe this is an internal cycle here. Maybe you're the only person using this data. It's not accessible, it's not discoverable, because you don't have a user yet, and really you haven't put the time in to think about how someone else might use this data. That's okay. Iterate on this data, and maybe you're producing other products from this. You could produce the resolution. You could produce static plots. This is level 2 storage. This takes less space, and maybe you have decision makers who are using these. This is like your education and outreach group who are using these type of products. So think about these things when you're going through your requirements. Come up with their user groups and the access requirements they have before you dive into your storage requirements. We've heard a lot about metadata. I mean, in order to get a catalog of discoverable metadata, you need to have a standard for storing that metadata. Preparing for this presentation in a workshop I led last week on video data management, just Googling around for video data standards, look at this list of things. There are dozens, and there doesn't seem to be a central resource, especially for drone data and video data and audio data, for how people are storing these. If there's even a widely accepted standard. Sharon mentioned embedding your metadata in the video. There doesn't seem to be a way to store this frame level metadata or this flight metadata inside of the video products. And that's an area that I came to this workshop hoping to understand more. It's like, where is that conversation happening? And who's working on that problem, and how can we all help? Because this is becoming a problem. There's more and more video data, there's more and more drone data. We have to figure this out now so we can access it and discover it. And we're not all coming up with our own standards. We're using the same one. Okay, how am I doing on time? Abby?
Sorry, Kyle, 3 minutes.
Perfect. I'm going to do 2 projects. I have some time. I must have talked quick. There are links in the web links if you want to play around with this while I talk about it. It's much more captivating than looking at static slides. I think you're all familiar with Alaska. It's a very large state. It has lots of shoreline. This is petabytes of data. Each red track line on that map is a flyover, and each blue dot on that track line is a static image taken during that flyover. So you can click anywhere on the track line, and you're warped to where the video and the stills are taken, and you can play along that track line. And I hope you guys are playing with it. You can play along with that track line and see it updating in real time. And this is for the entire coastline of Alaska. This was an initial project we did a long time ago, and it was unfeasible for us to store this data internally. The cost, it was cost prohibited. Even storing it in the cloud was prohibited. And we couldn't get cloud vendors to buy in and say, if you host this data, we think we have users that would use it. We didn't do that user analysis. We didn't have it. So we did what any desperate group would do, is we just used a free offering called YouTube that you're all familiar with. So this is petabytes of data that we uploaded as public YouTube videos, stored the metadata locally, and can link directly to them depending on where you click on the track line. We also have the analysis that people have performed using this data available, so you can look at biological wave exposure, sediment types on the shoreline, and things like that. So you can actually fly along and see the change. And again, I encourage you to play along. It's cool. Also, this is a project with Socorro. It's called WebCat. Now it's WebCoos. This is a different user group. This is web cameras up and down the Atlantic coast. Allows you to stream these data feeds in on the website. And that's a user group. That's a surfer. That is someone who's interested in beach conditions. Another user group for this were analysts, people doing machine learning on video data, who were studying different aspects of the ecosystem. So yeah, of course you could stream the data, and you can go to any 10-minute clip within the entire inventory of the data. But also, providing a very simple way just to download the data was instrumental in allowing these researchers to get their data done. And just giving this inventory graph really quickly as a visual representation of what was available, and because it's such a small amount of cameras, allowed people to really understand the breadth of data that was available. And with that, I am done.
Great. Thanks so much, Kyle. You raised some provocative questions about what we need to be thinking about as we make better use of this technology. So what I'd like to do now is go to some questions that have come up for all of our speakers. And I'm going to go back to the beginning. Some of these questions have been answered in the chat, but in case you haven't been following, I'll highlight those quickly. So for Julian, there was a question about how does Drone Logbook store the data from instruments on the drone? How's the link made between the drone and back to any data? And I think, Julian, you put in an answer, but would love for you to take a minute and explain to our audience.
Yeah, so some of the aircraft well, you do have the capacity to upload that data straight to the cloud. Drone Logbook doesn't have that facility, and because of the need for us to be able to work completely offline in remote locations, that's why we opted for the Drone Logbook software. We're also flying quite a few different aircraft, and the sensors more or less integrated, but the data streams off those aircraft aren't always accessible through the autopilot system. So that part of it is very manual in our system, and that's why we've opted for a simple naming convention that we put in the flight logs, so that when we transfer and create those folders for storage for the data, that the data, any metadata and that can get linked to that. And we can link it to the actual flight that took place and the flight records and those flight logs, and also as it goes right through the storage pipeline, that it's easy to find that data, and it's understandable, what sensors we used, rough locations, and what aircraft we used. So
great, thanks very much, Julian. There was a second question about whether the Duke software was open source, and it looks like you all used primarily commercial products modified for your specific purposes, and I think you may have touched on that a bit with your previous answer, but anything else you want to add related to y'all's software in your lab?
Yeah. Again, Drone Logbook was one that we were kind of a fairly early adopter with their software, so that gave us the flexibility to help drive some of the pathway that they were taking in terms of the data that we wanted to store and how we needed it to function. So that kind of directed that software, and especially the offline capability was very critical to us. So, but apart from that, the other Basecamp that we use for our project management and check room that we use for inventory management is just standard off-the-shelf versions of that, enterprise versions that we've tracked down that meets those requirements that we have.
Great, thank you. All right, next we're going to move to Sharon Misick. There was a question around whether the NOAA approach that you talked about during your talk was similar to what NASA or potentially other federal agencies are doing. Do you have any insight?
Honestly, I really do not. We did participate in an NSF workshop a few years back that was focusing on digital video management. I know that NASA manages a lot of digital data, and they have several locations where they do this. The other thing I can say is that with our strategies, we are reaching across organizations to look for common best practices, so those may emerge. So I don't have an easy or a fast answer to that, except that we're looking into it, I guess.
Okay, great. Thank you. And if anybody else has some information about that, feel free to type an answer in the chat. Now for Evan, there was a question about whether Survey 123 works in an offline mode, and I believe the answer is yes, but I want to give you a chance to address that question, Evan.
Sure. Yeah, it does work offline, specifically if you don't have any kind of connection to the cellular data network. When you return back into an area that has 4G, I believe you just have to open the app and submit it from there. So it doesn't do it automatically when you get back into cell service or back online, but yes, and that's specifically through the Android or iOS app Survey 123.
Great, thank you. So I think that was all the questions. Kyle raised a few in his presentation about where folks go to learn about best practices, to understand what standards are out there. He kind of had a question about whether there are already people working on these issues, and obviously we heard from some of our presenters that the answer is yes, and Sharon pointed us to a workshop that had just happened that may have addressed some of these questions. I just wanted to open that up to our panelists, and of course Evan talked about what's happening here in South Carolina. Any of our panelists want to address that question about existing efforts around standards or communities of practice that the audience might be interested in knowing about?
Deb, this is Sharon. In our Consortium for Ocean Leadership workshop, there was a pretty interesting discussion about what drives the requirement. So if the science mission drives the requirement, which is the norm, particularly in a federal agency, the scientists are looking for the platform and the sensors that are going to best meet their needs for the science. Data management, particularly long-term preservation, has its own requirements, and so what we're looking for is a balance, and I don't think we've achieved that balance, and that's a conversation that we need to have, and it's hard to know exactly who needs to be at the table. When every science program can go out and buy, a drone relatively inexpensively and manage the science themselves, and they manage the data for their project, it's the ad hoc management model for long-term preservation that we're left with, and it doesn't lend itself to big picture thinking about what the standards are. So the balance is between not inhibiting innovation or the best science with requirements, but being sure that the requirements are understood and are ubiquitous to the science. And we just frankly are not there yet.
Thanks.
From my
Sharon,
perspective, it's very hard. Yeah, it's very hard to tell, how do you get this conversation happening? Even in smaller subgroups. I think meetings like this are a place where we can bring these topics up and maybe form a broader community of practice.
Thank you. That's just where I was heading, that might be a gap that as an outcome of this workshop we could potentially try to address. All right. I am going to ask Abby and Stephanie to see if I missed any questions. It's looking like not, since we have the poll back up here. And a final question. Thanks, Stephanie. Would you be interested in a centralized location for drone imagery? And a few of you have answered, but I'd invite all of you to take a quick moment to hit a radio button and participate in the poll. And we're coming up on 11:10, so we'll leave this up for a couple minutes, and then we are going to take a 5-minute break. So would ask that everyone be back at their camera at 11:15. And we will have a wonderful mission planning presentation from our partners from the Duke Lab.
Thanks, Deborah. This is Stephanie. Just a quick note, we do have 2 polls up. One is the radio button variety. The other is for folks to actually type in some suggestions or comments on what a centralized location for drone imagery would need to include or look like or consider. So please also feel free to type some responses into that box as well. And I will keep these open at least for the next couple of minutes as long as I see people typing in. But do remember to be back from the break at 11:15.
Okay, Steph, am I good to start us rolling again? Yes. All right. So thanks all for participating in the poll. It looks like there's pretty overwhelming support for the notion of some centralized place for drone video. There were a lot of great comments about some sort of metadata archive being very useful. So thanks very much for your input on those questions. So next up we have Justin Ridge. He's a research scientist leading the coastal mapping efforts of the Duke Marine Robotics and Remote Sensing Lab. His work focuses on using remote sensing technology to monitor oyster reefs and wetlands in relation to sea level rise and other environmental factors. And he's going to lead a live demo on mission planning this morning. So welcome, Justice, and thanks for being here.
Thank you, Deborah. All right, I'm going to get some things activated here. All right. So in lieu of us actually being able to do an activity with you in person, we tried to develop a little exercise for us to go through, hopefully somewhat interactive, as kind of like a glimpse into our process of mission planning. And so can everyone see the slides and hear me okay?
Yes.
All right. So mission planning, we're going to get into a couple different aspects of mission planning, but I just want to point out that this is just as important as the actual operation of the drone to ensure that you have success in your drone operation. And this is kind of building off of something that Rhett Newton had presented at the last webinar, where he's trying to sort of come up with these very comprehensive best practices across sort of like how you would build your whole program and like how operations should be managed. And so we're just kind of like honing into aspects of project scoping and fieldwork parts, part 2 and 3. And I thought it would be a little bit more interesting to kind of couch this in sort of a choose your own adventure style. There's limitations with that, obviously, but this is a little cover of a choose your own adventure novel that I just edited for this purpose. Hopefully no one's drone operations actually end up looking like this cover. But I will say that having done a bunch of operations, drone operations on marine bases, that it doesn't look too different from this sometimes. Through this journey, we're going to have these different sections that we're going to go through, and different parts where I'll have you guys interact to help with this mission. And we're going to select a mission to begin with. We're going to think about some site considerations, choose our aircraft and sensors, and dive a little bit into the actual mission planning. So actually I'll go into some of the softwares that we use, and then go through a pre-flight check and reach our conclusion, which is either ends in glory or flames. All right, first up, so there's going to be a series of polls throughout this, and so the first thing that we're going to do is I'm going to have you guys choose what mission would you prefer to operate. And I've given you two options here, looking at hurricane impact to a barrier island or some sort of disturbance to mangrove health. I'll just give you a few moments to fill that in. Looks like everyone's filling it in. Wow, it's pretty even here. And that's perfect, because honestly, I'm going to talk about both of them. Yeah, nice split. Okay, all right. I'm going to start moving on then. We'll move on to the first. So before we get into the poll, Steph, I'm going to just talk about this. So our first mission is the hurricane impact, right? So we're going to be, we'll focus on that for these poll questions, but I'll also briefly discuss the mangrove operation as well. And so our next phase, we've chosen our mission. We're going to get into, what are we're doing some considerations for where we're flying. And so the area that we're going to fly is Masonboro Island, which is part of the North Carolina Coastal Reserve. It's this island. And here is part of an aeronautical chart, just so you have reference of like what that, not everyone may be able to read this, and that's quite all right. But I'm just going to open up a poll now. So our second poll will be, considering this environment, what are some site considerations that we have to think about? Yeah, and good point, Steph. This is part of the North Carolina NEAR system. I'm just going to give a moment to, you can scroll down. The poll may not show like all the question. Oh yeah, okay. Fold it down. Okay, that sounds good. Just to give you sort of a reference on the other site that I'll talk about, I was going to have us do some mangrove surveys here in Florida, near Oak Hill. So it's just north of Cape Canaveral. It's part of the Cape Canaveral National Seashore. And so when I talk about stuff with that, it'll be kind of in that context. All right. So in North Carolina, some things that we have to think about in this area for the Masonboro Island. There aren't too many airspace conflicts in that area, so it's going to be pretty easy to navigate that. However, North Carolina state requirements, this was talked about by Mike Griffin during one of the other webinars, that North Carolina requires you to have it's it's under the Department of Transportation, but it's basically their own version of an approval for you to operate unmanned aircraft systems. It's free, but you just have to go and do an online exam to get that in addition to your FAA Part 107 that you'd need to operate in this. The Masonboro Island, I said, was part of the North Carolina Coastal Reserves, so they like to, when you're doing research at the reserves, have a research permit. Just a quick application to them for them to keep track of things. Logistics, you're going to have to access the island, which requires you to access it from boat, so you'd have to get transportation to the island. You wouldn't necessarily need to operate from the boat. There's a lot of real estate on the island to operate from. There are times when it can be people heavy, so that's something you have to keep in mind when you're doing surveys and surveying over people. So you'll want to make sure that where you're flying, you're keeping track of that. There are particular times where it is heavy traffic, like July 4th weekend, but overall, you're not going to be dealing with massive groups of people. Yes, you have to worry about weather, because that's always going to be a consideration. And if you're doing an assessment, you'll probably want to try to target low tide if you can, just to capture the most amount of real estate. And as Steph points out, yes, animals, there are shorebirds and there's nesting seasons that you'll want to keep in mind when you're conducting these surveys. For that mangrove site, thinking about down in Florida, that is a little bit more of a complicated story in terms of airspace, and I'm just going to pop open. So there's a really handy tool that kind of helps you visualize airspaces that's available. You can download these files to Google Earth to see airspace overlaid the maps. And so there is a restricted area that's over top the area that the mangroves would be in. But if you were to look at the actual legend, and you can see it if I were to if I change this to a 3D view, but it actually ends at 11,000 feet. So the operating underneath it is fine. Let me go back. But you do have to be worried about, just make sure you're checking, that is Cape Canaveral, so there's a lot of activity around there, so just keep track of TFRs that are active and the notice to airmen that might be you need to check. There are state requirements in addition to the FAA, so one of the things that you might need, and we talked about this, Alex had brought it up at the last webinar, was that when you're operating around mangroves in the waters, in these areas, that the Water Management District requires a special use authorization for you to use that area. So that's something that you'd want to make sure you have. And as I said, this is in the Cape Canaveral National Seashore, and the National Park Service has kind of like a moratorium on drones unless you have obtained a research permit from them to be operating. And in this area, you'd be operating from a boat, so think about that. You're not going to really have the area to maybe even launch and recover your drone from shore because of how far away these mangrove islands are from. So let me bring up just kind of like a map to better show you where some of these islands. So you might be doing surveys around here. Too far from shore for you to maintain visual line of sight, which is something that you're always going to be operating in under FAA guidelines unless you have an exemption. And so you'll be operating from boats probably within the islands. And so that's going to kind of limit what you're able to use. You're probably not going to be dealing with a lot of people because you're out in the middle of the waterways. So that's less of a consideration that you'll have to have. And obviously weather, you're always going to be factoring in weather. And with mangroves, you're probably not as concerned about the tide for that. All right. All right, so we're going to focus in on, for these poll questions, we're going to focus in on the hurricane impact site. So thinking about Mason Borough Island, this is going to open up the next poll. What aircraft should we use for that? I'm just going to shut this off so we can maximize the share screen if we want. Steph. Yes. Okay. So with this poll, yeah, majority of people went for fixed wing, which I think is probably going to be the better option for the island. It allows you to cover a greater area, and with these kind of sandy, grassy areas, you've got some pretty good areas for safe launch and recovery of the drone. For those mangrove surveys, yeah, as I was talking about operating from the boat, it's really, you're tied to using multi-rotor aircraft and thinking about hand launch and recovery. And with some of these aircraft gives you boat modes, which kind of helps give you more flexibility with your drone initializing when you start it up, and it's maybe on like a moving vessel. You know, it may not be completely stationary, so that kind of helps it calibrate better. And your home point, you know, you may shift if you're not completely stationary and your home point has shifted. It kind of gives you more flexibility with that as well. All right, our next poll is we're going to talk about, so we're going to focus again on the hurricane. So what sensor do you think we need to have equipped for our hurricane impact assessment? We have a regular RGB, just normal digital imagery, multispectral imagery, or a thermal camera. Okay. All right. Well, this is not really a trick question. It's just more like it really comes down to what type of impact you may be looking at for that. Like, if you're looking at trying to look at 3D changes to the island, so maybe like topography, like loss of dunes or major washover deposits, you're probably going to want to go more the RGB route for the very high resolution RGB, which will really help with your 3D model creation when you're doing structure from motion. That will help with more of that structural change to the island. But if you're looking at, you know, impacts to maybe some of the vegetation, some of the different habitats, you might want to go more with the multispectral route and think about how you can get vegetation indices through the multispectral data. And so here I'm just showing you a couple different bands from specifically a mangrove island actually, but red edge, and near infrared bands. And then the red and near infrared are used to help calculate the normalized difference vegetation index in DVI here, which is an indication, helpful indication of vegetation health. And so that's something when we go back to like the mangrove islands, surveying those, multispectral imagery is probably going to be more helpful unless you're trying to do some sort of canopy assessments. And you may want to go more into the RGB or have that as well. All right, our next phase is we're going to start planning our survey. So we've decided on the aircraft and the sensors. And remember, we're going to be focusing on the hurricane impacts just for the survey question. What are the factors, what survey variables should we be considering? And I've kind of like given you a couple different options to weigh here. This isn't exhaustive by any means. It's just, you know, thinking about immediately what considerations you might have. Okay, all right. Yes, that looks good. All right, so with the, thinking about hurricane impacts and Mason Borough Island, which is a very long island, and how you would conduct your surveys, you're gonna want to, when you're planning your missions, you know, think about strategically like where your launch and recovery site's gonna be, your homes, because when you're tied to visual line of sight, you're obviously going to want to maximize your time by being able to see as far as you can and send that drone out in as few places as possible. So here, if we're just talking about we have a centralized home here, we can send out an EB. We can see it just under, you know, probably safely right around 1 kilometer out. Is what we're typically operating. So if you're situated in the middle of the island, you've got a 2 kilometer diameter essentially that you can be surveying in. With, again, coming back to what is your question, like are you looking at habitat impacts that might be more multispectral, or are you looking at 3D changes? If you're looking at 3D changes and you want some really deep, like accurate models, you might consider trying to do throwing in perpendicular transects to your parallel, so basically like a cross grid, to help build out that model. Now, some of the sensors, and I'll show this in just a moment, but there's sensors with like the EB now that are geared for 3D mapping, and they actually pivot on a gimbal while you're collecting imagery to collect nadir imagery, straight down imagery, and then oblique imagery as it travels. So you're kind of actually doing all of it at once. Then, yeah, you're obviously going to be, I mean, always thinking about battery management in terms of you have a finite number of batteries and you want to occupy, like capture as much area as you can. And so always thinking about how to maximize that. And we always like to land, we like to be coming back home sort of in that 35 to 40% battery life left. We don't want to be landing when we're dropping below 20%, because if something happens, you want to be, like say you have an aircraft incursion, so some plane is coming through and you need to like send your drone out to hover over some area while that passes through your area, and you're down to 15% battery life, you're going to potentially have some big problems. So that's what we try to be very conservative when we're flying, so that we don't have to be coming down to the wire with the batteries. Overlap, you might want to consider having a little bit higher overlap when you're flying over areas that are like flat, sandy, because your homogeneous textured surfaces, so like sandy, like really flat sandy with no ripples or, you know, a lot of like shells or whatever to kind of interrupt that monotony, can pose problems when you're doing 3D reconstructions. So to try to do that, that's kind of where a little bit of higher overlap, or maybe doing some like targeted perpendicular lines over those areas might help heal that area in the 3D model. And then ground control is another option. Like if you're, when we talk about ground control, we're talking about GCPs, so ground control points, that are these sort of black and white targets that we survey in, and that allows us to further make our models even more accurate in geolocation. The EBX that I'm showing you is as an example here has RTK survey grade GPS attached to it, so the pictures are already geotagged with very high precision accuracy. But you know, if you're talking about you want to get down into those like a couple centimeter level accuracy, you should consider putting out some ground control targets to help when you generate the model. You may not need that though if you're talking about areas where you're just trying to do some habitat assessments and it's a coarser look at what's going on in those environments. And then coming to the mangrove studies, here again, you're going to be, if you're operating from a boat, you're thinking about like, okay, how do you maximize, where can you place yourself in that environment where you can maximize the coverage you can operate from the boat. And if you're collecting multispectral data, you're really just thinking about parallel image transects. You don't have to worry about perpendicular necessarily, unless you're trying to do some very finite canopy volume assessments. And again, always battery management's a factor. Camera angle may be, you know, so typically with multispectral, you're just going to do nadir imagery, but if you are trying to do some 3D assessments of those mangrove islands, you may want to consider some oblique imagery as well. And another thing is, and I'll get into this when I show the actual survey, but when you're talking about like flying and you have glare issues, so especially when you're in watery environments, so in these islands, when you're taking nadir imagery, you might find that there is some big glare issues in certain parts of your imagery. So that's where we've done, you know, we'll strategically plan the missions so that you're sort of facing away from the sun and you're increasing your camera angle just a bit so that you're minimizing the amount of glare effects that could be happening. And glare effects can have sort of a ripple effect on like your products because of the way that they might like stripe things essentially as you move up and down transects. And I wouldn't, I don't think in this instance you're necessarily worried about ground control options. Overlap trees. Yeah, so overlap, not necessarily a huge issue, but we have noticed that when you're working in environments with trees, there are certain recommendations out there for when you're surveying trees, as in higher with a little bit more overlap is typically better because of the way that trees can move in the breeze, and that cuts down on the ability for when you're like actually taking lower altitude imagery, it might actually hinder some of your structure from motion capabilities. All right, so this next part, I'm just going to jump into actually showing you some of these software. So we're going to look at Emotion. I'm going to keep track of my time here. Really quickly, and then also another software that we use, which is Universal Ground Control Station, UGCS, that we like to use. So Emotion is SenseFly's proprietary software, and so this software is geared like for working straight up with their EBs, and It's a very powerful mission planning software. I've set up, so here we're looking at Masonboro Island, and this is, I just set up some simple corridor mapping transects. It's very easy to, you can adjust the resolution that changes like the altitude based on the sensor that we're using, the Area X here. And you can change your overlaps. It gives you all of your information about what your altitude at, how many photos are going to be taken, the estimated flight time, and that's always something we keep track of when we're talking about battery management and like trying to maximize and figure out like what we should be prepared for. And with the EBX flight time, like this is perfectly 40, we can do this in one flight and still be landing at around 30%, probably 30% battery. Yeah, and it's really easy to kind of set up, like if you want to, all right, I'm going to do a horizontal mapping box over the marsh back here. You can go in here and, you know, play around with how those, you can edit like where the flight lines, what direction they go in very easily. You can change your sensor cameras, and that all kind of trickles into the resolution and overlap. And there's an option for, this is where that perpendicular lines that allow you to do double grids if you're looking at like needing to do double grids and perpendicular lines in certain areas. So this is a really user-friendly software. We enjoy using it. But again, it's only for the SenseFly, like the EBs. All right. This is Universal Ground Control Station. And we like Universal Ground Control Station. It offers a lot of flexibility in terms of you can use it with a lot of different drones. So it's set up to sort of integrate with a bunch of different drones, and they're adding those a lot, and you can then add in payloads. So we have customized our Phantom 4 to have a Sequoia payload, so we can essentially create a profile in here that has our Phantom 4 with a Parrot Sequoia, which is a multispectral camera, attached to it, so that when we do our flight planning, we can have that factored in as our mission. And so this links up with, essentially runs through an app that's connected to the controller that allows you to feed into you use that instead of like DJI Go for the Phantom as an example. Here I've set up some surveys, and it's very easy to set up additional surveys all in like one big mission block. And UGCS is really good about here's similar to what we were doing with the EV. You can edit like how your flight lines are populated, where the direction they go in. You can change your overlap. So I've set it here. It's using the Parrot Sequoia sensor for its mission planning. So that's all the overlaps and the resolution are set by those sensors parameters. And you can see right now at 12 centimeters for the Sequoia, we're flying at around just under 100 meters in altitude for these flights. And you can do, so with these, if it's integrated, you can set your camera to be taking images by distance, or you can set it through time if you want to rather run it as a time lapse instead of GPS triggered. And so coming back to that glare issue, one of the things I really like about yeah, one of the things I really like about using this software, and some softwares now are becoming more flexible with this, but being able to deal with glare in some of these watery environments is you can not only set the direction that the drone is traveling for the transects, but you can set its orientation and tell it to face north, and so maybe it's like the sun is in the south, so it's always going to be facing away from the sun while it's taking these transects. You can change that slightly to any sort of degree depending on where the sun is in the sky, and you can also change its tilt for sensors like not necessarily if you just have a fixed sensor, like we have our Sequoia is just a fix, it's not on a gimbal, but if you, like the Phantom 4's onboard sensor is gimbaled, you can change its tilt to be 5 degrees, just so it's not pointed completely straight down where the glare might be getting worse. When you do that, obviously you have to kind of factor in the direction that your drone is traveling and how it's collecting images because of the way that it's calculating your lateral and your side overlap. Just to make sure that the side overlap is appropriate. All right, I'm going to go back to our presentation and quickly go through, because I realize it's 11:50. There are other softwares that are kind of available. Pix4D Capture is another one that our group has worked with, and that is nice because it works with an assortment of drones. It's not just the DJI drones, and it gives you a lot of flexibilities in the types of missions that you can conduct with that. Some other mission planning softwares to be just in the know that there's this before you fly, which is an FAA kind of app that helps you when you're planning on where you want to go. It's another one that helps you identify what kind of airspace conflicts and you might be running into. And then Maps Made Easy and Drone Deploy are two other software applications that are good for mapping, but also, again, those are more DJI focused. All right, we're running to our last poll here. So we're about ready. We've decided we've got our mission set up. We're heading to the site. What should be included in your pre-flight check? And this is just a short answer, so just kind of, you can feel free to shoot in whatever answers you want when you're talking about. So thinking about what we're going to do for the hurricane survey, what are some things you just want to make sure you're covering right before you fly? Yeah, and for the sake of time, I'm just going to jump right into it. I know everyone's putting in some really good information. Obviously, you're going to go, you want to inspect the aircraft to make sure there's nothing on it. Seems like it could be a problem. You check your lens cap, make sure you have memory cards, your batteries, your power levels, what the sensor settings you're using. If you're using multispectral data, be prepared for a radiometric calibration before you take off. The radiometric calibration is really important tool and what makes multispectral sensors so great. And yeah, wind, because that's also wind is a matter of whether or not it's safe to fly, but also like maybe think about that in terms of where how you're launching and recovering your drone. Check your fail safes. What is going to happen if your drone if there comes into a problem, and how you're going to deal with it. Make sure your ground crew knows its roles, and if appropriate, especially if you're hand launching and recovering, the proper protective equipment is good to have. All right, all of this is just to say that there are a couple different endings that could happen when you're planning your mission. Obviously, there are things that you want to avoid in this choose your own adventure. You do not want to come back and have total crap data. This is flights from a mangrove shoreline that did not turn out. And there are several things that have gone wrong in this processing that it's sad face. Also, I want to avoid the other ending where your drone has maybe experienced a catastrophic failure and sunk into the water or done some damage. We want ending 3, where you succeeded and you're triumphant. So that's all I've got for this activity.
Wow, thanks so much, Justin. That was incredibly informative and kind of fun. Appreciate the interactive opportunities that you provided. So I'm looking at the chat, trying to figure out if there are any questions. You also highlighted a number of resources. We'll be making those available on the website. So thanks again. I don't know if anybody has one quick question for Justin. Lots of kudos and thanks. All right. So Stephanie, maybe we can move to the closing slides. We do have an evaluation poll that we'd love for you to fill out. It's another quick radio button poll and also an opportunity to provide suggestions. Our next session is Thursday, October 29th. It is the final session in this series. We'll be focused on using drones to conduct species and wildlife management missions. So would love to have all of you back for that. Justin, if you're still on, I know you've been talking a lot, but there's one question. What was your most challenging but rewarding successful mission? From John.
I would say that would probably be actually the imagery I showed you of the mangrove islands. Those were in Belize actually, and so the whole mission planning for that was heavily involved, and there were a lot of lessons learned, and that comes with some of the data I showed you at the end that are crap. We definitely had some areas where we learned how to refine our surveying process for that. So it had kind of like the highs and lows, the good and bad, really. But I would say that was definitely probably one of the most rewarding experiences.
Thank you. All right, Stephanie, what have I missed?
There was one other question in the chat about the FAA labeling on the aircraft. I think Julian already answered that it is a requirement, and there is that label on all of the Duke drones.
Thanks for that.
Even if we didn't see it.
Well, thank you, everybody. The poll will be up for a few more minutes, and I just want to extend the thanks of the Planning Committee for your participation. Thanks very much to all our speakers, to Justin for the great demo, and we'll look forward to seeing hopefully many of you back for the session on October 29th. We'll be starting promptly at 10 a.m. And please do fill out the evaluation polls as you exit the session. And thanks to Stephanie for her great management of all things technical for this webinar.
That's very kind of you, Deborah. Thank you and all of our other great facilitators. I will be leaving the polls open for just a couple of minutes here, so feel free to continue to respond to those and add any suggestions for this session that you have in the text box over on the right. If you have any final questions for our presenters, you can type them in the chat. I believe all of them are still on, so hopefully if you type something in there, they'll be able to respond, as Julian is already doing now for other questions. Thanks again for your participation, and hopefully we will see you on Thursday.